Hey there guys, happy holidays and Merry Christmas and stuff. For this day I wanted to do another Lightwave video for Amiga, Lightwave version 5. This one I wanted to cover, again, trying to be as brief as I can, lights and surfaces. And I do mean these are really basic videos just to give you something to click on when you first fire it up. Surfaces, the last time we talked about scenes. Scenes are how you manage and load everything that you're doing in the program. Scenes contain objects and lights and images. So that's what a scene is, as we talked about last time. Surfaces are things that are attached to objects. So objects contain surfaces and images. And then lights are lights. Although you can use images with lights if you want to get some more fun stuff. But so you've got an object, and here you can see you've got a Romulan warbird here. When we go to object, I can see down here from the selected item, you get your object lister. This is all the objects that are in your scene. So I'll pick Romulan.lwo, and you can see it lights up the box and then highlights it to let you know that's what's selected. When we go to objects, it even shows it picked here. And here you can clear it, you can replace it, you can do a bunch of stuff to it. Again, this is getting to more advanced stuff. I'm trying to do really simple videos here, at least at the start. Surfaces. This is the current surface of the whatever is selected object. So keep that in mind, that you're only going to see surfaces for the object that you currently have selected. Or is that true anymore? Gosh, it's been so long since I've used this. Now I'm really going to sound stupid. I don't have another object in here to find out if that's the case. But I may have just... No, that's actually wrong. No, I'm sorry. That is a wrong thing, and I'm going to leave that in there because you know what? That's what happens. This is going to list all the surfaces in your scene, so in your project. This will have everything. So you should name these something that makes sense, that have some kind of association to the object. So in this case, it's a Romulan warbird, and these are all named _rom to let whoever's working on this know that these are the surface files that belong to the Romulan warbird. And you can see here, we go to objects, and the objects don't really have that kind of naming convention, which is something kind of sucks. Like, just to keep things clean, and so that if other people load your stuff, or you have to share it with people, like they know at a glance, like light clip head 2. What's that go to? What's light clip head 2? And then so you're like, I don't know what that goes to. So it would have been nicer to have named this like Rom_light clip head 2, so that the person would know, oh, this is all the Romulan warbird stuff, just at a glance. And again, this is going back to this version of Lightwave. Of course, with modern software, there's many better ways to manage multiple data sets and files and stuff, but just keep that in mind. So anyway, back to the surfaces. So in here, there's really obvious things. So like we'll pick head mid, and you're gonna see all these like yellow T's lit up, and like, what are T's? T's are textures, and textures are pretty much just images that you apply to surfaces, that you apply to your object. I mean, the most basic thing you can do, of course, is surface color. In Lightwave, when you adjust these color sliders, you get the little preview here, which is really convenient. But, for some of these things, if you want to get into more advanced looks, obviously you're going to want to apply a texture file. So when you click on texture, this is where you can load, go to the texture image, and you can pick the images that you've got loaded currently. So you would have gone in and loaded the images, which you do through the image editor. So you go to image editor. Again, this is pretty simple program to understand. Load image, and then you'll have all of your images eventually loaded in that you're going to use. And here you can see that's a really high resolution, 1000 by 1200. That's really high for this Amiga. I probably couldn't load anything else in here. Yeah, it's using 9.26 megabytes of memory. It tells you that right here. So I would probably scale these 50% using Art Department Professional or Fred to scale these down and save some texture space, because I'm not going to be rendering anywhere high enough resolution that I need that large of an image. So once those images are loaded, you go back to your textures and you can apply them. So the different apply modes are cubic, which is the most common, planar, cylindrical, spherical, and then you've got your procedurals, which are mathematical, randomly, fractally generated texturing instead of just using an image. But cubic is the most common, because what this simply does, and I'm not going to get into this advanced, these are projection styles. So this is like taking your image and just, like if you took a can like this and you just, let's say your hand is the image, Cubic is just like, hey, just take this image that's my hand, that's nice and dark, and just wrap it around this can however you need to make it wrap around the can. I don't care, just get it on there, okay? And that's what Cubic does. And there's the automatic sizing button that further assists in doing that. You smash automatic sizing, it'll just stretch the image over the entire surface to try and make it fit. Now, a can is a terrible example for using Cubic. And why is that a terrible example for using Cubic? Well, because you have Cylindrical. Cylindrical is the next smarter version, whereas Cubic is kind of the ultimate just dumb, do it please for me mode, and it just grossly applies the image to your surface as best it can, your object. You got Spherical, which, guess what? That'll wrap the image in a ball shape. So if you have a picture of the Earth that's like from a globe, so it has that distorted, wavy look to it, you can go on Google Earth, image Earth texture, and you'll see you use this Spherical mode to map things that are ball shaped. And then Cylindrical, again, with my can, for example, I could use that mode, and it would be a more accurate mode to put a texture onto this can. So like this can's label, which you can barely see, this yellow and white here and all the text on the side, you could just wrap the image. You could take the image that you made in your paint program and just wrap it cylindrically like this. Rip, rip. This is the most ridiculous example ever that I'm doing here, but I hope you guys enjoy this. So that's like a cylindrical wrap. And you control let's switch this to the cylindrical, I'll show you. You can control the axis that it does it on. So if it's gonna wrap it cylindrically, again, my hand is the texture, the thing you made it in Brilliance or D-Paint. If you're gonna wrap it, on this axis, or you're gonna try and wrap it on this axis, or you're gonna try and wrap it on this axis, that's what the axes are for. So for example, on a can, the axis you would probably use if you worked in a Y up would be like the Y axis. If you built your can in your 3D program just standing up like this. But this model that we have loaded currently is just using the Cubic mode. And if you go to texture size, you see these values in here, you're like, well, where did those come from? Why are these even numbers that are different? Well, those numbers were gotten there two ways. The artist who made this put those numbers in because when he designed the texture for this object, those are the numbers that were needed to stretch the texture to fit the object. Or he simply just smashed the auto size button using Cubic, and those are the numbers that it got, and that's how his texture turned out. It was good enough. I don't think that's what this is. I think this was more planned. But that just to give you an idea, that's what this is all about. That's what these different modes are: planar, cylindrical, spherical, cubic. Planar is kind of like cylindrical, and again, it's just a hard axis, X, Y, Z. So basically, you're mapping the texture flat like this, or you're gonna map the texture vertically like this, or you're mapping the texture flat like this facing you, like the camera. So that's what these axis modes mean. Again, if you're just starting out, just stick to Cubic, smash auto size. You may not like exactly what you're seeing on the thing you've created, but at least it gets you in a direction that you can start to understand how textures apply to a surface. And again, there's a lot more in here, but again, after you've just witnessed how terrible my basic example of this is, I don't want to get into any more details of this stuff. On here, again, you have these T's for all of these different channels: diffuse, spec. So luminosity is how much the surface glows or emits light. So like a candle would have luminosity, for example, or of course a light bulb would have luminosity. Diffuse level is how much light I'm trying to use simple terms here. I mean, there's things like, it's how much absorption it has, how much light it reflects back. In the simplest way to describe it, if you have a gray surface, you can make your color gray. The lower the diffuse value, the darker that gray is going to look with the lights you have. And eventually, if you set this diffuse value all the way to 0, no matter what texture you have or how much light you put on it, it'll just be black. You won't see any color on it. So this controls the amount of how much of that color or texture you can see with your lights. Again, I'm trying not to use the technical description for these. I'm trying to keep this really simple. And Specular, think of this as all of the lights that are in your scene, which could be the sun that you've made, or a spotlight, or a light bulb. This is how they will reflect on your surface. So let's say you make a ball and you put a little light bulb next to it. In addition to that light bulb lighting up the ball, okay, and it'll light the ball up, and if the ball is like, you made it red, it'll show up red as long as your diffuse level is set to, let's say, 100%, right? This will control how much of the light bulb itself shows up in that surface that you made. That's the specular. It's basically the reflections of lights. So whatever lights you have in your scene, this will control how intense they show up. And if you turn this on, for example, and then you can control their glossiness. This is like how sharp they show up. So if you have a really maximum glossiness, the reflection of your light in your ball will be a really hard, almost circle looking thing, just like the light is. But the lower the glossiness, the more diffuse and spread out that reflection of the light gets. So you get like a really nice, soft, white reflection of the light in your ball. And I could be showing you renders of balls right now and visually telling this to you much better than using my terrible words. But again, we'll do that later. So that's what specular does. And then reflectivity is much in the same way, except instead of lights, this is going to be reflecting other things in your world. So if you've got two balls, you could have one ball show up in the other ball's surface with reflectivity. Or if you have a cube next to it, the cube will show up. So specular level, this reflects lights, shows lights in all of your objects. Reflectivity is going to show everything that's in your scene in your surface. Kind of like a mirror. Think of this reflectivity as a mirror, basically, and specular is like another mirror just for lights. So you can see here computationally, as far as the math goes, if you use reflectivity, that's going to get really expensive, right? Because it's going to make the computer work really hard, because now it has to draw not only your items in your scene, it has to draw those items now showing up on all the surfaces in your scene, like having mirrors. Like remember, if you take two mirrors and face them face to face and how they bounce back and forth and you get the infinity mirror effect, you could recreate that by doing reflectivity 100% on two objects and have them face each other. And that's going to take a long time. So specular is a great way to cheat something looking reflective while not actually being set to reflective. But again, it's going to be limited to the lights, not actual items in your scene. And transparency makes things transparent, like soap bubbles and glass. That's what transparency does. Again, this is expensive stuff. Edge transparency, this affects the transparency. So again, if you have a sphere and you set it to normal, the edge of the sphere is just going to look like a bubble, okay? If you set it to transparent, and there's a control for that, once you set that, you get like this threshold control. This is how you can make the edge of the sphere look kind of fuzzy. So kind of like the atmosphere of a planet. Like if you look at a planet and you just set it to be transparent, it's going to be transparent evenly across the whole ball, and it's going to look a little weird. This is a way to cheat the edge of the transparency, or the edge of the sphere, to be more transparent and look soft, kind of like a soft glow on the edge of it. And then smoothing, this smooths all the polygons. Objects are made out of those little triangles. As you can see here, over here, the little triangles. This smooths them out so that you don't get the old classic 1980s, 1990s video game look where everything looks all angular. This will give the smoothing, and then you can control how smooth you want those things to be. And double-sided basically tells your object to always show up when you hit render button, no matter if it's facing away from you or not. And it's kind of a technical thing, but the object is composed of polygons, as we said, the little triangles. Some of them could be flipped, not facing the camera, but you still want to see them, right? So that's what double-sided does. It basically says, hey, you triangle, I'm going to be able to see you whether you're facing me or not. And a bump map is kind of a technical map. This is a thing that simulates bump, like crusty roughness on things. Like if you did a dirt ground and you put a texture map up here, a little T in color of dirt, and you rendered it, you'd be like, well, it looks like dirt, but it doesn't look like dirt. It's all flat. I can't see like bumpy rocks on it. Well, you put that same color map down here in bump, and then you'd get what looks like a bumpy, dirty ground, more like you'd expect. So that's surfaces. Now, that's surfaces. That's the most brief, poor, simple example of what surfaces are. But again, I'm just trying to get you guys slightly as best up to speed as I can with these controls here. So back to the Warbird, which has been sitting back here, which is far more exciting than what I've been talking about. So we're going to go ahead and hit the F9 button, which in Lightwave is the render button. And first off, over here in view, see how it says camera? So we know we're looking through the camera. And mouse mode, I'm in move mode right now, and in edit mode, I'm in object mode. So like if I was to move or rotate, this part of the Romulan Warbird would move or rotate, not the camera. So if I click on camera, now if I rotate, it's going to be the camera, which I showed in the last video. So if we go ahead and hit F9, Lightwave is going to go through here and do its thing. And yeah, I'll make you suffer through it in real time here. So it's doing its thing, it's applying some glow, and there you go. So you're like, well, that's dark and weird. It's kind of moody though, huh? It's like, ooh, moody. So what's happened here is that this Romulan Warbird has a bunch of those luminosity textures on it. So when I told you about color and diffuse and luminosity and specular, so what's happening here is that the diffuse color is like this green, it's using that green texture. And then to do all these windows, they put in a texture of little tiny squares to look like windows into luminosity, which makes the surface illuminate or transmit, look like it transmits light, you know, nice and bright. And so you get the windows. And then they're doing the same for the engines. They put they made the engine color green, and then they put a luminosity texture in there that drives it up to 100% to make it nice and bright green. So it basically, these luminosity textures don't need sunlight or any light hitting them because they emit their own light. And then there's a fancy like glow effect happening on here that's happening with another feature you can do. So the thing is, that's great. You're getting to see, as I said back here, you're getting to see luminosity textures in action. That's how you do lights on ships. But you know, we need to see the ship. So we can go to the lights button and we can click add light. And I always like to name the lights. I'm gonna rename this light, and we're gonna call this something really difficult, sun. And let's just for now, set it to 100%. We're gonna say it's a distant light. This basically tries its best to simulate the direction of the sunlight. So no matter where it's pointing, it's gonna cast light. There's no out of range. There's no way your objects will like not get hit by light, okay? Unless the light's completely facing away from them. So this is like a giant, that's why I also like to call it distant sun, because it's just trying to simulate the actual sunlight of light just coming from everywhere. Point lights are more like light bulbs. So they have a radius and they affect things in a radial spherical pattern. So it would be very easy to have a point light next to something and it wouldn't be lit up if the point light wasn't set to a large enough radius. And a spotlight is much like you think. It's a spotlight, like you'd see in the old theaters where you got the spotlight, you know, shining down on the actor on stage who's doing amazing things. And the spotlight comes with all of its own controls. And for this case, we're going to do ray tracing because why not? That's, of course, the most expensive but accurate way to render lights or shadows or reflections, all those other good things. Again, it's getting into more advanced stuff. Shadow maps are far more faster and efficient, and almost always that's what I would use. It's a way of quickly faking or rasterizing ray traced light. So we're going to do this anyway, this ray traced light. So now what we're going to do is go into edit mode light, and there it shows up, and we're going to move it. Now, because this is a sunlight, it doesn't matter where it's at. This light can be over here, up here, up here. It does not matter where it is at. So you can move it wherever you want so you can best see it. What does matter is its rotation, because again, it's a directional light. So wherever this light is looking is where it will actually cast light. And what I'm going to do here is go into perspective mode to get a better idea. There's my camera. So now we're looking at the perspective view. And if you hold down the left, is it the left Alt key? Yeah, the left Alt key and left mouse button, you can rotate around in this view. It helps you get kind of an overview of what the heck is going on. And it's very useful. And again, we can switch to move, and then you can just left click like everything else, move the light back. So I'm like, okay. Now I noticed like I'm moving the light here. We're in perspective view. Now when I held down Alt, we were rotating the view. So why when I went to move? Well, as soon as I let go of the Alt key, watch what happens over here. Alt to rotate around the perspective view, yay. And then watch over here, when I let go of the Alt button, all this stuff changes. It's gonna default back to whatever edit mode you were in last. So I was in light, so it goes back to the light. If you want to move the view around, you need to be in edit mode view. Now, in addition to doing what we did before. And when you do this, you don't need to even hold down the left Alt. You can just, because now you're in the actual view edit mode, you don't need to hold down any keyboards. You can just use your left mouse button, click and hold and rotate. And then you can click on move, and then you can move around. But the whole reason I did this was so that we could see the light and verify, because it's kind of hard in the camera view to see, is this facing the object? Because unfortunately in these simpler graphic times, you know, they try their best to show you this little, you know, wireframe box of the light. But I mean, depending on how your left brain, right brain works, is this light facing us or is it not? You know, we already know from the perspective view that, yeah, it's not facing us. So if we go back to the camera, now knowing it's not facing us, now do you see it? Oh yeah, it's opened up this way. So I need to rotate it this way, and now it'll actually be pointing at the spaceship. And then we'll do the enter to create a keyframe for the selected item. We talked about this in the last video. So now when I hit F9, hopefully we should see a spaceship. Oh, look at that. Okay, so now you see a spaceship. Yay! And it's using the ray trace light. So that's why if you look under here, it's still dark. And that's because the light is directional, and its light beams are pointing in a way that don't get up underneath the ship. They're only coming down at a certain angle. So it's like shining a flashlight on a model kit at home, right? Although a flashlight is more like a spotlight, but that's my point. That's why it's still dark under there. If we went back and we took this light and let's say pointed it straight up, and maybe this way, we'll create a key. Hit the F9 button again, F9 to render. Now you can see it looks like it's being lit from the bottom because it's being lit from the bottom. And there you go. Now the whole underside is being blasted. Even the light, because the way I angled that light, it's even the bottom of this ship isn't blocking the light from getting up there because of the way the light's angled. So that's how it gets up in there. But obviously it looks cooler. That's why you'll see a lot of times when you're going to light something cool, you light it more from one side. And I think the auto key is on, so I keep doing this when I move the light. I keep creating a keyframe, but I'm pretty sure if I just rotate it, it'll remember that. Yeah, it remembered it. So if we hit the F9 now, the light will be, yeah, so now you get the cool rim light. It's like, ooh, they call this rim lighting or a kick light. And spaceships always look really cool when you do this. So now you get your cool rim light on there. Now, this is way too dark. I mean, is it accurate for space? Like the sun? Sure. Yeah, I mean, the sun's only coming from one direction, so this is accurate. But there's what's accurate, and then there's what's, you know, what really looks cool. Now, for some folks, they're like, this looks cool. Don't do anything else. But what you could do is you could very quickly just go ahead and add another light and call this one Phil. Hey, Phil. And not rename. And I'm going to change the color to just a little bit of a blue. Kind of a, actually, no, let's do a little more of a purple because, you know, space purple. I'm going to keep this as a distant. I'm going to keep it at 50%, so it's only going to be half as bright as the main light. And I'm actually going to turn off ray trace because this is just a personal preference for fill lights. I'm actually going to turn this down a little bit too. Ultimately, I would use probably a shadow map spotlight so I could have nice soft shadows instead of hard dark line shadows. But for the sake of wrapping this video up, again, edit mode, we're going into perspective. It lets you know what view you're in up here. We were in camera, so it says camera. And then now we're going to click on perspective. Now we're in perspective. Making sure I'm editing the light, still editing the light. I want to move it out of the way so I can see better what it's doing. And now I'm going to rotate. And you can rotate it in this view. It's fine. And then, you know, you can keyframe it in this view. That's also fine. And go back to 6. Now we can see. So we know the sunlight is over here from the right, blasting it this way. So now this is going to come in and fill it in from the left. So we're going to do that. I'm going to go down here and pick the sunlight. Again, everything in your scene is in this item list down here, so all your objects. So let's go to sun, and I'm going to actually rotate that sun a little more. Oops, see, I can't tell which way that's going. So I'm going to click in here. I'm going to rotate a little more to the right so we get a little more of the nose lit up. Okay, now we're going to hit the F9 button again. Yeah, so we got a little bit more of that nose lit up. Now we should have some of the side of the ship. So there you go. Now the side of the ship is kind of getting some soft blue, purplish fill light on it. Again, on my camera, this is probably not coming out so great. On the camera, it probably looks exactly the same, depending on what the iPhone is doing with exposure. But there is a nice little soft kind of purple-blue kick in these darker areas now. I don't think the phone's picking that up at all, unfortunately. But you'll see it when you do it. So that's it. That's a quick coverage of surfaces, which was, I know, probably a really long and boring section, but at least now you understand what these T's mean and what it is these different things might actually do. And then how to add lights, create lights, how to then employ them in your shot, how to make use of the perspective view to help give you a better overview of what the heck is actually going on in here. Again, you know, edit view, we can move it around, or rotate view, we can rotate around the view. Perspective view is a great way to get an overview of where the heck everything is in your shot. You can even see your little camera over here. So when you pick camera for edit, hey, look, you can see where your camera is going. You can even see what your camera is seeing. And then when you go back to view, camera, you're looking back at the camera. All right, guys, that's 26 minutes long. So sorry if it's too long. For those of you stuck around, congratulations and happy holidays.